Hello, everybody. I'm going to do some more on strings today, and this will be leading to your next homework. So the first thing I want to do is I want to remind you that every character in ASCII code is represented by an integer in the computer. So we want to go back and forth between the two. The cast is a way to convert int to char or char to int. I mentioned this once before, but I didn't spend much time on it. It also will convert some other things. I believe it'll convert an int to a double. But what I want right now is the int to char and char to int. So, for example, int of quote a quote is the integer that represents little a. Now I don't happen to remember that, so let's look it up. I'll just pull up an ASCII code and let's see, little a is represented by, that's capital A. Let's see if I can find the little a. There it is, 97. And that's the decimal version. So it's represented is 97. Okay, girl. My cat is walking behind the screen. That's why I said, okay, girl. Sorry about that. Also, for example, char of 99 is the character of 97 is little a, 98 is little b, 99 is little c. Now this can be very useful, playing around with many things. It can be kind of nice to go back and forth. So what I'm going to do first is I'm going to write a little program that will allow us to look at this. I've already written it, but let's take a look at it. So this program is a converter. It's going to take me back and forth between integers and characters. I'm also introducing something new here, a version of the while loop. So let me write that down too. There is a second version of the while loop in the form do whatever you want to do while, and then whatever you want to put inside the parentheses. The point, and that's lowercase d, of course. Here she comes again, pardon me. Every time she goes past the computer, she goes right between my microphone and my camera, and I'm afraid she's going to knock one of them down. The point of this, in this case, in this version, we always do the loop at least once. Since we do the loop once before testing for the condition. Now that can be useful in some cases. I'm going to use it in this particular case because I think it fits better. But, it's a choice. Some people like it, some don't. So here's what I'm saying. I'm going to ask you, I'm going to write a little program. I'm going to let you convert between character and integer. We're going to go back and forth. I'll ask you to put in a character, I'll convert it to an integer. I'll ask you to put in an integer, I'll convert it to a character. I'm going to give you a choice. Which way do you want to go? And there are three choices. I want to convert to an integer, I want to convert to a character, or I want to stop. Now, I'm presuming you're not going to stop at the beginning. But you'll notice what I do is I ask the question inside the loop. If you looked at many of the other things I've done the question once outside the loop, and then I've entered the loop and done it again. This time I only have to do it once. Because if the choice is C, I'm going to ask you for an integer, and I'm going to print it out, the character of it. If it's I, I'm going to ask you for a character, and I'm going to print out the integer. And I'm not going to do anything if it's S. I'm just going to get down to the while and in the while loop. Notice that I need to have this bracket, this brace before the while, because that brace ends the brace that's up by the do. I'm playing a game with my cat here. She keeps going back and forth. I'm sorry. Now, here's the cast. It turns the integer into the character that's represented by it. And this takes the character into the integer that represents it. So I'll run a few of these so we can see what happens. So the first thing is I want to convert to an integer. And I'm going to convert capital A. And that's 65. And I think I'm going to convert little a. And that's 97. Notice they're not the same. That's why we have so much trouble making sure we're case sensitive. Let's convert cap B. How nice. It's one more than cap A. The same thing is true for little b. It's one more than little a. Let's try 8. Well, you might think that 8 is an integer. It should be 8. No. Oh, pardon me. I made a mistake. Sorry about that. Integer. I want to convert 8. 8 is the number 5, 6. Seems strange. Let's convert 9. 9 is the number 5, 7. Well, at least they appear to be in order. That much is good. 1 more than 8 seems to be represented by 1 more than what represents 8. So we got some things working here. Now I can stop, but more is going to happen. So I'm just going to wait a while, and I'll come back to what the more is here. So we can play a lot of arithmetic with this. Notice here, C plus 4. C is a character, and yet I added 4 to it. Now, what happened there? Why in the world, what's that going to be? Now I take C plus 4, and I cast it into a character. And then I subtract cap A from C. Well, the question is, what are these things going to be? Are they going to be integers, or are they going to be characters? So what is C plus 4? Let's see. I'm going to stop the program here for a minute. I'm going to int nothing cn nothing. What that will do is it'll stop the program at that point, so I won't have to worry about going on to the rest. So let's see what happens. I'm going to stop this immediately. And now let's see what we got. Little bracket t plus 4 is a number. So it appears a character plus a number is a number. But I can cast that into a character form, and guess what? It's X. Now, if you count on your fingers, X, Y, T, S-T, U, V, W, X. Well, what do you know? C plus 4, bracket T plus 4 is X, 4 past T. Exactly what we would like. Now, what about subtraction? Does it do the same thing as addition? Yep. C minus bracket A equals 19. Well, C is T, right? A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. I bet I got 20, but that's because I counted A. I should have started counting at 0. T is the 19th letter of the alphabet when you're starting with 0. So C minus A, as you would expect, is the number of the 19th letter, T. So all of that's going to get us some good things in a minute or so. I'm going to get rid of these now. I don't need them. And now what I'm going to do is do some unusual things. But first, let me go back here. I want to say when we add or subtract a character and integer, we get integer. That's what we saw in a minute ago. That's what it comes out. So if we want to turn it back into a character, we have to cast it. Now let's look at some really, let's try something. Many years ago, there was a man named Julius Caesar, whom most of you have probably met in your first semester of Western Civ. And in Caesar's commentaries on the Gallic War, he mentions a secret code. We replace each letter with the letter three above it in the alphabet. Now that seems to give us trouble for the last three letters of the alphabet. But as usual, we go around three above it in the alphabet, where A is one above Z. So we just go around the circle. Think of the alphabet as a circle. When you get to Z, you start back at A. That's a pretty common way of doing things. This code is one of the codes called Caesar codes. We can vary the 3 to any number. Today, this code would be so breakable that we wouldn't even think of having it. But apparently, Caesar had enemies that he felt couldn't break it. I don't know why. I think they could have broken it. But I guess he felt that this was a reasonable code. I don't know how many of you remember Caesar's commentaries. If you had Latin in high school, you probably remember Omnia Gallia est divisa in tres partes, the beginning of the Gallic Wars. Some of us had it beaten into us. Now, how am I going to write this? Well, that doesn't seem terribly difficult. I'm going to try several different methods. So let's go back here and let's start with, now I got to save this. I'm going to start with a new project and I'll call it Caesar Code 1. And I'll have my using namespace standard. And what I'm going to do is I'm going to have an alphabet. So my string, now I can use uppercase or lowercase. It's whatever we feel like. I think I'm going to use uppercase and put everything in uppercase. So I'm going to have lowercase, lower, and I'm going to have it be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And then A, B, C. Seems reasonable. Notice I added 3 on the end, so I don't have to go around. Now I'll have another string that will be my text that I'm going to bring in. And the common term for that is the plain text. That's the text that isn't encoded. And the term for the encoded text is the ciphertext. So I'll ask the user, I'll begin by saying, cout, what number do you want to use for the Caesar code? And I'll just do that, and I'll cin, we'll call it offset. It's a reasonable name for it, and that means I better declare it int offset. Now, from there, I'm going to do the following. Let's get rid of that and all of this below it. So, I'm going to read in the text. And I'm going to make life easier for me. The text isn't going to have any spaces in it. I remember I could fix that easily. I wrote a program the last time to erase spaces. So I'm going to say cout input text in lowercase, no spaces or punctuations. So let's see. We will cin text. And now I have several things I can do. I think I'm actually going to add the # include string because there's something in the string group I want to use. I can get away with it without it, but I prefer to have it. So what I'm going to do, I have to call it plain text. I'm going to go through it one by one. And what I'm going to do is I'm going to start by setting the ciphertext to equal nothing. Now that sounds stupid, but the problem is that there's a very technical point that when you're going to be doing the appending that I'm going to be doing in a minute, I need to start somewhere. And I need the somewhere to be a string, not a character. So that's why I use the double quotes. Now all I'm going to say is for int I equals 0, I less than plain text dot length I plus plus. I am going to take ciphertext, have it equal ciphertext plus. Now here comes the fun stuff. I want to get into the alphabet. I know that if I have a letter, I can subtract A from it and get the number of the place in the alphabet. Well, that's the same as the number of the place in lower. So what I'm going to say is do the following. Go into lower. Take plain text, bracket I. Subtract A from it. And add 3. Add offset. Again, what I'm saying is, we found out a minute ago that if we take a character, minus a character and add a number, it should come out to a number. Now, I could be fooling this. It could be I need a cast in one place. In fact, I'm thinking I do. I suspect that I can't do this without casting as an int this part here. But we'll see. It's always fun to experiment. So let's see what happens now. That's it. So I'm just going to see out ciphertext. End out. And then my return 0. And I think I got it all. Probably an error or two, but let's see what happens. Yeah, I knew something was going to go wrong. Too many characters in constant. Now, what's the reason for that? Before I fix it, you tell me. Look at it and you decide what you think the reason is. I'll give you a minute or so. I'll give you a little time. What's the reason for that error? Remember that lower is a string. It is not a character. I need the string notation. Now it also said there's something wrong at line 20. I don't know if that is fixed or not. This is the problem with with all kinds of parentheses, etc. I had that in there when I didn't need it, so it's there. It goes away. Now let's see if that works. All right. This is an example of Z's. Nothing came out. Absolutely nothing came out. My strong guess is that I don't need this. So let's see what happens now. This is a test of Z's. Still nothing. Okay. When this happens to you, the first thing you do is you look to see if you can find out what's going on with this particular item here. So what I do is I'm going to see out plain text bracket I minus point A minus A. Now what I'm doing is I'm trying to figure out whether that's a character or a number. So let's see. And everything looks okay otherwise. So run it now. This is it. You know what I'm doing wrong? Oy vey. Pardon me. I can't believe it. I forgot to put the number in. 4. This is a test of Z. T. STUVW IX, that's 4 past it. Let's see. Z, what's 4 past Z? That doesn't look right, but we'll take a look at that in a minute. I know why that's not right, by the way. Uh, and then we have, is there an A in there? Yes, it's the 1, 2, 3, 4, 5, 6 place, and the A should become an E. The mistake is I set this up for 3. I need to have D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. That will allow me to go up to 26. Or at least, yes, 26. So it now gives me the chance to do what I have to do. So now let's see what happens. I'm going to do 3, and I'm going to say hi ho. Hi ho. Zozo. ZZ. It should be enough. Effigy. H. IJK works. I. JKL works. O. PQR works. Z. ABC works. So the program works. And what we've proven is that we do need the cast inside. We don't need the cast inside there. It took care of it without the cast. So that works pretty well. Worked very nicely. Got what we wanted. It is one way to do it, and I will write that one out for you in a minute. So let me delete that because I don't need it. And I'll run it once more because I want to save it. I'll use 1, and I'll do hey. I'll just do hey, and 1 past it. F, G, H, I, E, F, Y, Z. Okay, so let me copy this. And that's the first thing we'll look at over here. Now, some of us like to live dangerously. And there are some very fun things we can try here. There's a way to do this where I do not have to put that string in. But you're going to probably not like it. I'm going to try a second method. So what I'm going to do here is I'm going to say, let's take the letter. So I want to replace a letter X with the letter, let's say, offset past it. Now I'm going to begin by saying, let's take the letter X and subtract A from it. Now, if you remember, X minus A should be a number. It's how far away. So this is the number of X in the alphabet where A is 0. So now we have that. Now let's take that number and add offset to it. So x minus a plus offset is almost offset past it. Well, we have to remember that we need to do a mod 26 because we want to know the position of it. Now also, we don't want this to be a letter. It might be okay. That might be a number, so we're okay there. Now I go and say, that is the position of the letter I want in the alphabet. So why don't I add A to it to get the number? And since that's probably not the character, let's put char in front of it and make sure it becomes a character. And I did it again. Keep putting the wrong thing there for mod. Now, I think in my program, I may actually have added an int in one place. I don't know if it's necessary, but we'll see. That, I think, is close to working. So let me go back to the program. Let me copy the whole program. Control C. And now I'll use a new program. And we'll call this Caesar 2. And I'll begin by copying in the new program I had. And now I'm going to try to put something else here. What I'm going to try to put here is what I had back here. So I'm going to see if I can slip that into there. So I'm going to do, that was nice. I got nothing on that one, so I better go back and redo it here. And now go back and slip it in here. I think I can slip it in here, actually. Well, I don't know what's happening. It's refusing to do anything. Let me try it again. It doesn't want to put anything in there. Try it once more, being stubborn. And I'll try the other way just to make sure. Copy. Now I'm going to go back to here. And I'll just do paste. Oops. I need edit. There it is, paste. Well, it did work. So I don't know why it didn't work before. Now we need the semicolon. Well, let's see if it works or not. The machine is not happy because of a problem. The problem is that Word does not use the same thing for a single quote that C++ uses. I don't know why. So let's see what the machine says to us. I thought it might complain. An undeclared identifier? Oh, X. That makes sense. Because it was supposed to be plain text I that I put in there. So I was supposed to put in here plain text I minus. That was the problem there. So let's see now if it works. A, B, Z, T, hello. Nothing. I did it again. Pardon me. A, B, Z, T, hello. Well, I got a mess, didn't I? It didn't work. I had a feeling all along that I had to put an int in somewhere. I also have a problem here that I've got all kinds of crazy things going wrong, so I better play around with this. It's not what it was supposed to be. The minus A was supposed to go there, plus the offset mod 26. So that part was here. Then I was supposed to add A to that. Now I think that's what we did. I got to check on all my bracket, my parentheses. That one is there. This one carries that, and there needs to be one more here. I think that covers it, but I still don't think it's going to work, but we're going to try. This is ABC XYZ. That's the third time. This is ABC XYZ. Well, that's even worse. So as I mentioned before, I think I need an int right here. I need to make that an int before I add the offset and before I mod it with 26. No. I won't forget this time. This is ABC XYZ. Nope. I'm going to go back to what I had written already earlier before I came on and see what I did there that worked right. And that for some reason or other, no, that isn't the one. It's one back. It's the example one. Here's what I wrote that did work. So I don't see where I made a big difference between that one and the one I had, but let's compare the two. So we'll take that. We'll go back and close the solution. And we'll go back to CSA code. Now I want CSA code 2, pardon me. So we'll go back to CSA 2. And I'm going to put in what I have here and compare. I have cat A plus int. This time, this is plain text I. Now, I did subtract the A as I was supposed to. I added the offset. And you'll notice that I have a different parentheses set up here. I do this, add the offset, and mod 26, and then turn it into an int. So let's see if perhaps that will work. I have no certainty, but I hope it will. And I need to get rid of this, and I need to put this here. Now let's see. Control X. This is ABC 3. This is A, B, C, X, Y, Z. That worked. So I'm going to take this and copy it into the notes so we can see how it works. So let's go back to here, copy this in here, and look at it step by step. And this was X. So X minus A is the number in the alphabet counting at A as 0. So that was the first step. Then X minus A, I took that and I added to it the offset. That is the number of the code for X. So let's see, did I miss any parentheses? No, that one's there. Oh, I haven't done that yet. So now I have this plus offset, and now at this point, I take the mod 26. I believe it's at that point I do it. So I take X minus quote A plus offset, and I have to be careful here because it looks like I have to put the mod 26 in first. And that corrects for rounding the corner, rounding the end of the alphabet. So I have that. There was a 1 there, and I forgot to put that in there. So now I have all of that. Now I add, and now I make it an integer. So at this point, I say int of this entire thing I add up there. So whatever this was, I copied it down here, and I added another parentheses, and I think you'll see that it's working so far. 2 parentheses after the int, and 1 here. Then add quote A quote to get the character, to get the number in ASCII code number. I had the number between 0 and 25. And finally, convert to CAD. So that works. Now, you might say, you gotta be kidding. Nah. Sometimes we try clever things. Sometimes we try different approaches. That happens to be a different approach. It's more sort of based on the numbers of things rather than on the string itself. So maybe some of you like it, maybe some of you don't. Maybe most of you don't, but that's that. So that's what I'm going to finish with at this point. The next thing I plan to do is send out a homework that involves taking a plain text and converting it to code somehow. I don't know if it'll be a Caesar code. It may be something a little different. So we'll see what happens. So long now.